2 points, x and y-intercept, slope and y-intercept, slope and a point. How can you use these 4 conditions in order to graph the equation of the line? If you don't know, then finish this video and I'll teach you how. But before anything else, hit that subscribe button and notification bell for you to be updated of these School Clear Math videos just like this. Hello Math Learners! Welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash, and today we're going to discuss the most essential learning competency-based lesson for Quarter 1, Week 6 of the Grade 8 Mathematics. And this is all about graphing the equation of the line or graphing linear equations. Now, as what I've said in the introduction, we will use 4 different scenarios in graphing the equation of the line. The first is by the use of 2 points. The second is the x and y-intercepts. The third is the slope and the y-intercept. And the fourth is the slope and a point of that certain linear equation. So, let us start. Okay, math learners, we are here with an example, y is equal to x plus 2. This is a linear equation in 2 variables because the 2 variables are x and y, and the highest degree is the first degree, which is a linear equation. Now, how do we graph this equation using 2 points? Remember that in graphing, we need ordered pairs, meaning the coordinates of the points in order to plot them in our Cartesian plane or the rectangular coordinate system. But if you have a given that is an equation and you are asked to use 2 points in this given equation in order for it to be graphed, then what will you do? Okay, this is how to do it. Remember that this is your equation, right? Now, you just need to assign 2 values of x. Okay? So, let's say the first value of our x is 2. And the second value of our x is, let's say, negative 3. Okay? Now, how do you get the points based on this given values of x? Okay? So, you will substitute this value to your equation. So, what you will do is y is equal to 2 plus 2. So, therefore, your y is 4 when your x is 2. Meaning, the ordered pair is at 2, 4 for the first ordered pair. Now, how about here? We have y is equal to, we will change this x into negative 3. That is negative 3 plus 2. And negative 3 plus 2 is equal to negative 1. Therefore, our value for y is negative 1 if our x is negative 3. So, the ordered pair is negative 3, negative 1. Remember that in writing the ordered pair, you will always start with x. And then you write the y. You write the x and then the y. So, how do we plot this? Okay, so we will plot first 2, 4, and then negative 3, negative 1. Okay, so we have here our Cartesian plane. This is also known as the rectangular coordinate system. This is the y-axis and this is the x-axis. We have 2, 4. So, positive 2 for x and positive 4 for y. 1, 2, 3, 4. So, therefore, we will see our point here. Okay. Next thing you should do is, you will plot your second ordered pair. That is negative 3, negative 1. Negative 3 is here, negative 1, negative 2, negative 3, okay, for x. And then for your y, negative 1, that is here. So, therefore, your point is here. Now, having 2 points, what you will do is you just connect the 2 points and then you put an arrow at the end of those lines. So, this is how to do it. Easy, right? So, let us go to our second example. Okay, math learners, we have here our second example. We have y is equal to negative 3x plus 4. Now, graph this linear equation using 2 points. So, how do we do that? Again, we will just consider 2 values of x. So, you have all the choice what x that you want to use. Okay, so I will choose my x is equal to, let's say 1. And the other one is, let's say, positive 4. Okay. So, now, what we do here is we try to solve the value of y if our x is equal to 1 and if our x is equal to 4. Okay, so let's start. So we have here y is equal to negative 3. I will change the x into positive 1, okay? And that will give me negative 3 plus 4, which is equal to positive 1. Therefore, my coordinates are 1, 1. Easy, right? Now, how about 4? We have y is equal to negative 3 times 4 plus 4. This will give me negative 12 plus 4, which, if I add this is different signs, so this will become negative 8. Okay, so, for my ordered pair, I have positive 4, negative 8. So now I have my two ordered pairs, and the next thing you should do is to plot these 2 points or these two ordered pairs to your rectangular coordinate system. We have 1, 1, so that is positive 1 for x and y. So that is located here. Next is we have positive 4, negative 8. So positive 4, that is 1, 2, 3, 4, and negative 8 for y. We have 1, 2, 3, 4, 5, 6, 7, also here. Okay, so let's just, okay, so that is here. Okay, so we have plotted all the points, and now is to connect the points to make it align. And here it is. And that is how we graph our equation to our Cartesian plane. Now, if you might ask, Sir Ash, can I extend my line until I touch the y-axis? Yes, you can do so. Even here, you can also extend your line at the bottom. Okay? So that is so easy for us to consider 2 points. Now, let us consider, how about if we think about x and y intercepts? Okay, math learners, we are here with our example, 2x minus y is equal to 4. Now, how do we graph this linear equation using the x and y intercepts? Remember the definition of x and y intercept. X-intercept is the intersection of the graph into the x-axis, while y-intercept is the intersection of the graph to the y-axis. Remember that the coordinates of the x-axis is basically a 0, while the y-intercept is 0, b. Remember always that the y-coordinate of the x-intercept will always be 0, while the x-coordinate of the y-intercept is always 0. Okay, so how do we do this? Technically, you just need to substitute your y to 0 to get the value of x-intercept. While for the y-intercept, you substitute the x to 0 and solve for the value of y. How do we do that? Okay, let's start first with y is equal to 0. So that is 2x minus 0 is equal to 4. So we have 2x is equal to 4. Divide both sides by 2. And x is equal to 2. Therefore, our x-intercept is at 2, 0. Easy, right? Now, for our y-intercept, we will make our x is equal to 0. So we have 2 times 0 minus y is equal to 4. So 2 times 0, that is 0. So that is 0 minus y is equal to 4. 0 minus y is negative y. That is 4. Divide both sides by negative 1. Okay, that will be cancelled. And we have y is equal to negative 4. Therefore, the coordinate of our y-intercept is 0, negative 4. So how do we do this? Basically, this is very easy. If you have an x-intercept and a y-intercept, you will have points that is basically in the y-axis and the x-axis. Okay, so our x-axis is 2. So that is here. Easy, right? And our y-axis is negative 4. So that is here. 1, 2, 3, 4. Negative 4. That is here. So therefore, just connecting the dots or just connecting the points, you will have your line. And here it is. So much so, my dear math learners, that is very easy. Okay? So now let us consider another example. Okay, math learners, we are here in our fourth example. We have y is equal to 3/4 x. This is an example of a slope-intercept form, right? Okay. So remember, in the slope-intercept form, that is y is equal to mx plus b. Now, why am I saying this to you, my dear math learners? Remember that if your linear equation is in this form, you don't need to solve for the value of your y-intercept. That is the number that is after your term with an x. Now, as you can see here, you don't see a number after the term of your x term, right? So, if that is the case, then we already know that our value for y is at 0, 0. Easy, right? Now, how do we know about our x? Okay, so this is how you know for x. So what you will do is you just make this a 0. So that is 0 is equal to 3/4 x. And then you cross multiply. So that will be 0 times 4 is equal to 3x. So still the answer is 0. And that is 3x. Divide both sides by 3. This will be cancelled. And x is equal to 0. Therefore, the value of your x is at 0, 0. Okay. So the question now is, how do we do this, my dear math learners? We have an x-intercept at 0, 0 and a y-intercept at 0, 0. Okay. So that is here. Now, with just 1 point, can you make a line out of this? Basically, you don't have any sufficient technique, right? But I will teach you how to do it by the use of your equation. Now, since the two intercepts, the x and y, offers the same coordinates, therefore you have only one distinct point, how will you make your line? This is the time that you will consider the value of your slope, the rise over run. Remember that m is your rise over run. So how do you do this? You will go up and then you will run. So we have here 3/4. 3/4. 3, we will rise 3 times, and then 4, we will run 4 times or 4 units. Okay. So this is our point, right? Okay. Now we will rise 3 times. Since this is positive, that is 1, 2, 3. Okay. And then since this is also positive, our 4 denominator, we will run at the right side. So that is 1, 2, 3 for our rise. And we run 4 times 1, 2, 3, 4. So that is basically here. Okay. So now you have the 2 points and now you can make your line. So how is that? This is how it is. Easy, right? Now let us go in using slope and the y-intercept. Okay, math learners, we are here in our third part. We have using a slope and the y-intercept in graphing your linear equation. So how do we do that? We have here an example, 4x plus 5y is equal to 20. Now, if this is the case, what you can do is not to substitute any values. What you can do is you just change your standard form into a slope-intercept form. Because in the slope-intercept form, by just looking at it, you can determine your slope and your y-intercept. First is we transpose our term with the x. Okay? So we transpose it to here. We have negative 4x. And then we copy plus 20 because we did not move anything there. And then we divide the whole equation by 5. Okay. So that is y. And then negative 4 over 5. So that cannot be simplified. So we just copy. 20 divided by 5, that is positive 4. So therefore, our slope is negative 4/5. And our y-intercept, okay, is 4. Now, what does y-intercept mean? So, in here, what we can do is we plot first our y-intercept, and that is positive 4. So, that is 1, 2, 3, 4. That is here. And then, we will use our slope. This is negative 4 over 5. Negative 4 means we will go down 4 units. And positive 5 means we will run at the right part of the Cartesian plane. Okay, so we have here our point for the y-intercept. Then we will go down 4 units. 1, 2, 3, 4. Okay, that's here. And then we will run 5 units. 1, 2, 3, 4, 5. And this is the point where our next ordered pair is located. Now, what you will do is you just connect the dot. And this is how it is. Okay? So, very easy, my dear math learners, in using the slope and the y-intercept. Now, let's consider another example. Okay, math learners, for our next example, using the slope and y-intercept, we have here 2x minus 5y is equal to 15. Again, if your equation is given in the standard form, what you can do is you change it to your slope-intercept form. By transposing, we have negative 5y. Our 2x will become negative 2x. Our 15 will become positive 15 because we did not change that. And then we divide the whole equation by negative 5. That will be cancelled. We have y, alright? Negative and negative, that will also be cancelled. 2 over 5, we cannot divide 2 by 5, so we will copy 2/5 x. And then, positive 15 divided by negative 5, that is negative 3. So, therefore, our slope is positive 2, 5, and our y-intercept is at negative 3. So, what you can do here is first, you plot negative 3 in the y-axis. Okay, and that is here. Because 1, 2, 3. Negative 3. Okay. And then, since both numerator and denominator are positive, therefore, we will rise and we will run on the right side of your Cartesian plane. So, you rise 2 units. 1, 2. Okay. And then, you run 5 units at the right. 1, 2, 3, 4, 5. And this is your point. Okay. So now, you have your 2 points, and what you will do is, you connect them. And this will be your graph looks like. Easy, right? Now, let us go to our final part, or final condition, that is using the slope and the point. Okay, math learners, we are here in our last condition, that is using slope and a point if your linear equation is this one. X minus 3y is equal to 15. Now, how do we do this? Now, there are 2 ways to do this. First is you can change it into the slope-intercept form so you can know what is the slope. And the second is by considering first your point. Okay. Now, let's say the value of our x is 6. Okay. So, what we will do is we substitute 6 minus 3y is equal to 15. Okay. So, since we cannot subtract this because they are not like terms, we can transpose our 6, giving us negative 3y is equal to 15 minus 6. Okay? So, that will give us positive 9. And here, we divide both sides by 3. Negative 3. Cancel them. Okay? So, y. So, 9 divided by negative 3, that is negative 3. So, therefore, our ordered pair is 6, negative 3. So, this is our point. Now, the next thing you should do is you get your slope. How do you get the slope here? You can just transform this to a slope-intercept form. So, that is, you transpose the x. That will give you negative 3y is equal to negative x plus 15. Okay? And then, we divide both sides by negative 3. Cancel. So, that is y is equal to negative, negative. That will give us positive. So, that is 1/3 x because 1 divided by 3, we cannot divide them. So, that is 1/3 x. 15 divided by negative 3, that will give us negative 5. So, our slope here is positive 1/3. So, what we will do is we plot first our first point and then we will use our slope. So, this is positive 6, negative 3. So, where is positive 6, negative 3 located? So, that is 1, 2, 3, 4, 5, 6. Okay? This is the x coordinate. And then, negative 3. 1, 2, 3. So, this is the place. Okay. Alright, sorry. Okay. So, this is it. Alright. So, that is our first point. Now, where do we go to our second point? We will use our slope. We will rise 1 unit and we will run 3 units to the right because it is positive. So, that is 1 unit. So, this is the one. Since this is 3, right? So, the 1 unit is here. Okay, we rise. And then we run 3 units. So, 1, 2, 3. So, that is here. Okay. Now, if you want to know what is this location, that is, since this is 6, 7, 8, 9, that is 9, negative 2. While this one, this is at positive 6, negative 3. Okay. So now, very easy. What you will do is you just connect the dots. And this is your graph looks like. Okay. You can extend it here. You can also extend it there. You have your choice as long as the points are connected. So I hope you have learned a lot of things on how to graph linear equation using 4 different conditions. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time today in our discussion here in ML with Sir Ash. If you do have any questions and inquiries, do not hesitate to write in our comment section below. This is still your free access math teacher Ash, and always remember, it is fun to learn mathematics if we are together learning. I just like to shout out our dear subscriber in this channel, and this is the one. Now, if you wanted to have cool and interesting videos to watch, then try subscribing her channel as well. Thank you very much. Take care and God bless you always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.